stopped to think about what's actually inside your phone or your laptop? We're always talking about the software, the apps, the cloud, but who builds the physical world all that stuff runs on? Well, today, we're pulling back the curtain on the invisible architects of our digital age. Let's get into it. I mean, seriously, think about it. Who designs the tiny, complex chips, the intricate circuit boards, the routers that connect everything? Who takes basic stuff like silicon and copper and turns it into the absolute magic we use every single second of every single day? Well, that would be the computer hardware engineer. These are the brilliant minds working in labs, designing and testing the physical guts of our technology. They are the essential link that takes a cool idea on a whiteboard and turns it into a real physical device that you can actually hold. So what does a hardware engineer actually do all day? It's not just soldering stuff together. It's a whole journey, taking an idea from a simple sketch and wrestling it into a working piece of tech. Let's break down what that really looks like. Now, on paper, the process looks super clean and organized. First, you design, right? You're drafting blueprints and schematics. Then you build. You're actually making physical prototypes and tweaking them. Next step is testing. You're running all kinds of analyses to make sure it works. And finally, you collaborate, working with the software teams to make sure everything plays nice together. It's this constant cycle of create, test, repeat. But yeah, let's be real for a second. That's the textbook version. The reality, it can be a little more chaotic. As this very honest engineer on Reddit put it, it's a high-pressure job. It often means a frantic, last-minute scramble to get everything done. It's really the perfect blend of structured genius and, a little bit of panic. So how do you manage that blend of genius and panic? You need the right set of tools. And I'm not just talking about a soldering iron. To really succeed here, you need a balance of two very different kinds of skills. On one side, you have the hard skills. This is the deep technical stuff, programming in languages like C++, designing those complex green circuit boards, the PCB layouts, and using tools like oscilloscopes to see electrical signals. But just as important, on the other side are the soft skills. We're talking analytical thinking, creative problem solving, and a huge one, collaboration. See, hardware has to work perfectly with software, and that means you're constantly talking to other teams. All right, now this entire field is right on the edge of a massive, massive change, and it's all being driven by one of the most powerful forces in tech today, artificial intelligence. This is the next generation of manufacturing and design. So here's the problem we're facing. As chips keep getting smaller, the designs are getting way, way more complex. That means designing them and, more importantly, testing them to make sure there are no bugs is becoming this huge, time-sucking challenge. We're honestly pushing the limits of what a human team can do. And this diagram right here, this is the solution. It's from a cutting-edge research paper, and it shows an intelligent agent powered by a large language model. Yeah, like the tech behind ChatGPT. But this AI isn't replacing the engineer, no way. It's becoming a powerful co-pilot, an assistant that can understand what you're trying to build and help automate the whole process. And what this AI co-pilot can do is just incredible. It can automatically write and debug the special code used to design circuits. It can create the super complex tests needed to make sure those designs are flawless. And it can even optimize for what we call PPA. That's the holy grail of chip design: low power, high performance, and a small area. This is a game changer. It frees up the engineer from the tedious work to focus on real, next-level innovation. Okay, so after seeing where the future is headed, you might be thinking, all right, I'm in. How do I get started? So let's lay out the actual path to becoming a computer hardware engineer. And honestly, the path is probably more straightforward than you think. It all starts with a bachelor's degree in computer engineering or something similar, like electrical engineering. And here's the key part. While internships are a huge help, most entry-level jobs don't actually require prior work experience. That makes it a really accessible career for new grads. And the reward for getting those skills, well, it's pretty good. The average salary for a computer hardware engineer is over $138,000 a year. So yeah, it's a challenging job, but you are definitely well compensated for it. It's also a pretty secure career path. The projected job growth is sitting at 5%, which is faster than the average for all other jobs out there. That means demand for hardware engineers isn't just high, it's growing. So let's just quickly recap that career snapshot. You start with a bachelor's degree, you don't need prior experience to get your foot in the door, the pay is fantastic, and the job outlook is really strong. It's a field with a clear path and a very, very bright future. So look, the invisible architects of our digital world are more in demand than ever before. The tools they use are getting smarter by the day, and the things they're building are only going to get more complex and more amazing. The foundation of our future is literally being built right now. So the only real question is, what part are you going to build?